Okay, let's look at this problem. We have some function of x with unknown parameter m. M is a positive rational number. And here we go, we're going to part A, find in terms of m the x coordinate of the stationary point of the graph. Okay, so in approaching this problem, first off, let's draw on the idea of a stationary point. Stationary point occurs when the derivative of the function is equal to 0. So let's differentiate, equate it to 0, and then we need to start going ahead and transposing it for x. So taking the log of both sides and then dividing by that negative 1 over m, that negative m, and we'll end up with something like this. So that allows you to see what the x coordinates are, stationary point. Okay. Alternatively, we could have an answer of this form, negative 1 over m, natural log of 3 over m. That's also correct. Now let's look at B, the next part, which is the second section. State the values of m such that the x coordinate of this stationary point is a positive. So for x to be positive, we need our here m value to be positive, of course, but also that log. Something about that log has to ensure x is positive. And anything where for the log to stay positive, the argument of the log, being that part, has to be greater than 1. Okay? Because log of a fraction, such as log of 0.5, well, that's a negative number. So the argument must be greater than 1 for it to have a positive value. And that means that m has to be greater than or equal to 3. Okay? Now, part B. For particular value of m, the tangent to the graph of y equals f of x at x equals negative 6 passes through the origin. So we're told that we have some graph with a tangent at negative 6 passes through the origin. So let's try a little graph here. It might be something along the lines of graph that looks like this, perhaps, and at some value we're going to get here, maybe at negative 6. We're going to have a tangent that passes through the origin, like that. So that's essentially as what the question is depicting there at some point. And that point there is when x is negative 6. And our job is to find what is the value of m in the function for f of x. Okay, for that situation to occur. So let's try. First off, let's see that, okay, a tangent to the function occurs at x equals negative 6. Well, let's consider the gradient, just the gradient of the tangent. So the gradient is df dx, but at the point x equals negative 6. So let's evaluate the gradient at that point. And we worked out the gradient in part A. So we substitute negative 6 into the expression that we worked out in part A. And then, well, that's one way of working out the gradient of a tangent. The other way is to find the gradient of a line using that rule. y2 minus y1 over x2 minus x1. So that's another way of getting the gradient of the tangent. And if we take these two expressions for the gradient of the tangent and equate them, put them together at a particular x value, like x equals -6 for corresponding y value f of -6, giving this coordinate there in terms of m, and the other point is the origin, so that's our x1 and y1. We put that together and we equate it to the derivative, and we can start to transpose, by multiplying by the -6 the other side and then inverse operations, and we'll see that we can collect all our terms to the left hand side, equate it to 0. We've got a common factor of e to the power 6m, factorize that out, and there's a null factor theorem. We're able to see, well, from that m must have the value of 1/6, because the other one, e to the 6m, cannot equal to 0. It's asymptotic along y equals 0, so it can never actually equal 0. And there's our answer. M equals 1/6. Very good.